And today we are going to learn work, energy, power, formula and also concept. Okay. The first we'll see what is work done. Work done is equal to force into displacement. Force into displacement. Actually it is a scalar quantity. So it is a scalar quantity. So work done is equal to F S cos theta. So the product we are using as a cos theta. Whenever we are using cos theta, which is we are going to call it is a scalar quantity. In case it is a sin theta means we have to tell it is a vector quantity. Force is a vector quantity. Displacement is a vector quantity. Because of cos theta, just I am making here it is a dot product. Dot product is representing as a it's a scalar product. So work done is equal to Fs cos theta. So force is vector, displacement is vector. When the two vector is multiplying, the answer is going to be the scalar. It is called scalar product. So work done is equal to Fs cos theta. The next one, energy. There are two types of energy is there. So energy, there are two types of energy. One is a kinetic energy, another one is a potential energy. Kinetic energy, we can take it of mv square. So the formula for the kinetic energy of mv square. M is the mass, v is the velocity. Some of the case initial and final velocity also will be there. So that is a case you can write kinetic energy is equal to of m v square minus of m u square. So change in kinetic energy. This we can call it is called change in kinetic energy is equal to of m, I am taken common, v square minus u square. Many of the case u will be 0, initial velocity will be 0. So kinetic energy will be of m v square. The next case we are going to see what is a potential energy. Kinetic energy is called mechanical energy. So which is we are going to call of mv square. The next one, potential energy. So potential energy is equal to mass into gravity into height. So m is the mass of the object, g is the gravity of the object, h is the height of the object. In case I consider one object at some height, the mass of the object will be acting downwards. From the ground it is h height. From the ground it is h height. So work done is equal to Fs cos theta. So as we know, weight and displacement will be the same angle, cos 0 degree. So Fs cos 0 degree. Cos 0 will be 1. So Fs. Here force is called weight. Here force is called weight, which is we are going to call mg. So displacement we are going to call it is a height. So mgh is equal to work done. So actually we learned three formula. One is a work done is equal to Fs cos theta. Another one, kinetic energy. Kinetic energy is equal to of mv square. The next one, potential energy. Potential energy is equal to mgh. Okay. So now I am going to give you what are the unit of the energy. Whether it's a work done and energy, the unit will be the same. So we are going to learn different kind of unit. So first one, work done. Work done is equal to force into displacement. So work done, energy, both will be the same. Whether it is a potential energy or kinetic energy, whatever energy, the unit will be the same. Work done. Now we are seeing what is a SI unit. Work done is a joules. Force is a Newton. Displacement is a meter. So this is we can call it is a SI unit of energy. SI unit is which is follow as a MKS system, meter, kilogram, second. So 1 joule is equal to 1 Newton into meter. What is 1 Newton? Force is the unit of 1 Newton. Force is equal to mass into acceleration. Force is Newton, mass is kg, acceleration is meter by second square. Just I am substituting here. So kg meter by second square, which is we are going to take it as a Newton into meter. So kg meter square, second minus 2. From denominator I am taken second square as a numerator, plus 2 is going to change as a minus 2. So which is we are going to call solution for the SI unit of work done or energy. Work done and energy will be the same. Now I am going to tell you what is a dimensional formula for energy. So dimensional formula. Mass we have to take it m, length we have to take it l, time we have to take it t. So its power of 1, it is square, it is t power minus 2. It is the dimensional formula for energy, work done, potential energy or kinetic energy, whatever is there, we can take it. This is the dimensional formula. Okay, next one, the other unit of the energy. Other unit, we have many unit for the energy, especially 9th and 11th. We'll get in 12th also, we'll get lot of unit for the energy. Just I'm reviewing all the unit. Okay, 1 joules. So 1 joule we can write as the energy work done. The unit will be the same. 1 joule is equal to Newton meter or kg meter square second minus 2 we can write. The another unit, EV, electron volt. Electron volt also is the energy. So 1 electron volt, electron value 1.6 into 10 power minus 19 joule. The next one, mega electron volt or million electron volt, 1 MeV. Now we are learning different unit for the energy. MeV, mega electron volt or million electron volt. It is 10 power 6 into 1.6 into 10 power minus 19 joule. This answer we are going to get 1.6 into 10 power, this power addition we are going to get minus 13 joule, 1 MeV. So right now we are learning different unit for the energy. The another unit, so another unit we can take it as a ERG, energy unit we can take it as a ERG. What is ERG? So the same unit already we know, 1 joule is equal to kg meter square second minus 2. The same unit, it is followed in a meter kilogram second. The same unit I am going to write it in a centimeter gram second. Centimeter gram second. So instead of joule we can write as a ERG, instead of kilogram we can write as a gram, instead of meter we can write as a centimeter, instead of second will be the second only. Okay, so 1 ERG is equal to 1 gram centimeter square second minus 2. The next thing, relation between ERG and joules. Relation between ERG and joules. So 1 joule is equal to dash ERG. 1 joule is equal to dash ERG. So 1 joule is a kg meter square second minus 2. Right now this unit I am going to convert in a gram centimeter second. So it is 1000 gram. It is a meter square 100 centimeter square into second minus 2. So this value we are going to get, because 1 meter is 100 centimeter, meter square is a 100 square. Okay, so it's going to be 30 into 4 zeros, because 100 into 100 10,000 gram centimeter square second minus 2. So 1 joule is 10 power 7 ERG. So right now we will get what is ERG. ERG is a gram centimeter square second minus 2. Now ERG to the joule, 1 ERG is equal to, this I am bringing here, 1 divided by 10 power 7 joule, which is going to be 10 power minus 7 joules. So 1 ERG is equal to 10 power minus 7 joules. This also I got. Next, this what the very important concept in the, it is there in for the energy. Okay, next thing, power. So power is equal to work done by, power is equal to work done by time. It's a rate of doing work also we can say. Power is equal to work done by time. Otherwise energy by time also sometime we can call. Okay, work done by time. So power unit will be watt, energy unit will be joules, time unit will be second. So 1 watt is equal to joule second minus 1. Just from denominator, second I am taken as a numerator. Okay, joules already we know, kg meter square second minus 2. Already we know what is 1 joule second minus 1. So kg meter square second minus 3. So right now power dimensional formula. Power dimensional formula. So for mass we can write kg, we can write m, length we can write l, time we can write t. So it is 1 time, it is 2 time, it is 3 times. Okay, dimensional formula for the power. Dimensional formula for the power. Okay, the next thing, the relation between power and energy. So next I am going to give you relation between power and energy. Power is, power unit we can take it as a watt, energy unit we can take it as a joules. So relation between power and energy, power is equal to work done by time. So just a cross multiplication. So this is 1 watt is equal to 1 joule per 1 second. Okay, what is joule? Work done is equal to power into time. So 1 joule is equal to watt into second. Okay, so watt into second we can write as a joules, it is called energy. Joule per second we can write as a watt. That is the relation between power and energy. Power is equal to energy by time or work done by time. Anything we can take it. Okay, right now we learned what is the relation between power and energy. The next concept. So next concept we are going to learn what is kWh, kilowatt hour. So kilowatt hour is a unit of energy. It is a unit of energy, kilowatt hour, which is we are going to call commercial electrical unit. We are going to take it as a kilowatt hour. So 1 kWh is equal to dash joule. 1 kilo is a 1000 watt. 1 kilo is a 1000 watt. 1 hour is a 3600 second. So 3.6, 1, 2, 3, 4, 5, 6 zeros I am taken, like a power 10 power 6 watt into second. Watt into second. Watt into second already I told you it is called joules. So it is going to be 3.6 into 10 power 6 joules. So 3.6 into 10 power 6 joules. In case example 3 kWh. So this month you used electric bill as a 3 kWh. So it is 3 times of 1000 watt into 3600 second. So this multiplication 3.6 into 10 power 6 into 3 times of watt second. So that's going to be 3.6 into 3 into 10 power 3 joules. Just a simple calculation. So we will get what is a 3 commercial electrical unit. 3 times of commercial electrical unit. In case you are getting the electric bill as a 5 rupees. 3 unit is how much? 3 times of this value we will get. 3 times of this value we will get as a electric bill. That is we will learn in another video. Okay, next thing I am going to teach you what is a conservation of energy. So conservation of energy. So energy neither be create nor be destroyed. Conservation of energy. Total energy will be constant. Okay, if example I am taken a ball at some height, the total energy is equal to kinetic energy plus potential energy, both together. So I consider ball at some height. So ball at some height here. Okay, it is a point of A, it is a point of B, it is a point of C. So at A point maximum potential energy will be there. There is no motion in this particular point, mgh. Kinetic energy will be 0. Kinetic energy will be 0. At B point, so at this particular point both will be off of. Kinetic energy will be off mv square, off mgh. Potential energy is equal to of mgh. So at C point, so ball is fully came down. When the object is some height, the maximum potential energy. When it comes to the ground, maximum kinetic energy will be there. There is no potential energy, there is no energy stored in this particular object. So kinetic energy is equal to mgh, potential energy is equal to 0. I'll give another example. Here the energy is stored 100 joules. Okay, when it is coming here, kinetic energy 50, potential energy 50. The kinetic energy already converted 50 joule. The potential energy remaining is there for 50 joule. Okay, when it is come to the ground, total kinetic energy is converted into the potential energy. So 100 joule potential energy, total potential energy is converted into the kinetic energy. Okay, the total energy is constant. Here total energy will be mgh. Here also total energy will be mgh. Here also total energy will be mgh. The energy neither be create nor be destroyed. The total energy is going to be the constant or conserved. Okay, neither be create nor be destroyed. In this case, we are going to take it air friction as a negligible. So I'll draw one graph. See here, I am taken 3 point A, B, C. So A point, B point, C point. Okay, A point, potential energy is maximum, kinetic energy is minimum. Okay, so it is called kinetic energy. So when it is comes to the B, potential energy decreasing, kinetic energy increasing, everything off. Okay, when it comes to the C, potential energy will be 0, kinetic energy will be maximum. So total energy will be constant, which is going to be mgh. Okay, so this is called conservation of energy. The graph I did displacement versus energy. Okay, the same concept we can use for the simple pendulum also. When the pendulum is oscillating, I am taken 3 point A, B, C. A, B, C. Okay, this I consider as a ground. So this have the potential energy. Potential energy means stored energy. If you left something, it's going to do. Okay, here potential energy is going to be mgh. Kinetic energy will be 0. At this point, when it comes to the ground, kinetic energy will be mgh, because here there is no energy stored. Potential energy will be 0. When at the point of C, kinetic energy will be 0, potential energy will be mgh. How we can find potential energy is maximum? When the object is some height, the potential energy will be maximum, because it's a stored energy. So at A, at B, at C, potential energy, kinetic energy, total energy. So just see here, it is a point. So kinetic energy is mgh, potential energy is 0. At B point, potential energy is mgh, kinetic energy is 0. Here also at C point also same thing. It is a potential energy mgh, kinetic energy will be 0. It is called total energy will be kinetic plus potential mgh, mgh, mgh. Total energy is constant. Okay. The next we are going to see how the graph is going to be for the simple pendulum and also work energy theorem. It is a point of A, center point. It is a point of B and it is a point of C. Okay, first I am drawing graph for the kinetic energy. Kinetic energy at the A point maximum, B point minimum, C point minimum. So I will get like this inverted U symbol. Okay, at B point potential energy maximum, at A point potential energy minimum, at C point potential energy maximum. I will get like a U symbol for it is a kinetic energy. It is a kinetic energy and it is a potential energy. Sorry, it is for kinetic energy and this is for potential energy. And total energy is maintaining as a constant, conserved. Okay, energy neither be created nor be destroyed. Okay, and the final one, work energy theorem. The relation between work and energy. So work done we are going to call Fs. Work done we are going to call, work done is equal to energy. That's only we are going to call it is a work energy theorem. Work done Fs. Energy, kinetic energy of mv square minus of mu square. It is called change in kinetic energy. So work energy theorem says force into displacement is equal to change in kinetic energy. That is called work energy theorem. Okay. So in this video we learned so what is the work done, what is a potential energy, what is a kinetic energy, okay, what is work energy theorem, okay, unit of energy, unit of power, okay, conservation of energy, okay. The next thing, graph also we learned, then power. Okay, these are the concepts we learned. If you like my channel, please subscribe. Thank you for watching my channel. Thank you everyone.